Hello pre-calc students, Mrs. D here. We're going to look at a few problems off the back side of your study guide that might also be causing you some pondering. So, number 23 is a solve problem where you need to find the solution, and it looks a little bit complicated, so I'm going to use my properties of logarithms to condense these two. So first of all, I'm going to put that 2 into a power and that 3 into a power. Then I'm going to make this into one logarithm. So it's going to be log of that sum is going to turn into a product. So it'll be 16, that's 4 squared, x to the third, and this is equal to 2. Now notice that there's no base written here, so that means we must be in the common base, which is 10. And so if I utilize what I know about a logarithm, the base, even though I don't see it, is 10. A logarithm is a power, so that 2, what it's equal to, is my power on 10. And this is the result. So the base is here. This is the exponent. This is the result. So this 10 squared should equal 16x to the third. Now we just need to solve for x. Well, 10 squared is 100. And then maybe we divide by 16. X cubed then is equal to this number, whatever it is. Let's divide by 4. 25 fourths. And now if I cube root both sides, I should have x, which is approximately 1.842. So we don't get an exact answer there, but I bet if you plug that back in for x, you would get something very close to 2 out of this equation. Number 28 is a graphing problem, and we seem to struggle quite a bit with log functions, graphing. So let's remember the key features of a log graph. First, there's a vertical asymptote at 0. Second, we have a point here that passes through 1, 0, because for any base, log base b of 1, the power that you take that to is 0. That will give you 1 every single time. That's why that point's always on this graph. And the function generally increases. So, how does this graph change? Well, this is a base of 2, but it's still going to resemble that log graph. This 2, and if I rewrite this, it might be a little more obvious what that 2 does. That 2 is going to shift us up 2 units. And then there's a negative in front of the log, which will reflect it over not the y-axis, but the x-axis. And now we just got to kind of put that into action. So if I shift it up 2, the vertical asymptote is still in place. If you had shifted it left or right, the asymptote would have moved. Now if I shift right, not right, up 2, this point that was here at 1, 0 is now going to be up 2, or at the coordinate 1, 2. Now, the whole graph isn't going to be shaped like this anymore. If I reflect over the x-axis, it's shaped like this. So I'm going to expect to see that kind of a trend here, but we need at least one more point. And oh, I like getting points. All you got to do is plug in numbers. So I've got a base of 2. Let's use some numbers that are friendly with 2, like 2 and 4. So if I plug that in, log base 2 of 2, for example, is 1. And then if you take 2 minus 1, you get 1. So there's the next point, 2, 1. And that fits that trend that I was expecting to see. Now if we plug in 4, log base 2 of 4 is 2, because that's the power you would take 2 to, and we get out 0. So there's another point, 4, 0. Follow that vertical asymptote, and then trend downward and to the right. Once you have some specific points there, you've got a pretty good graph. Last problem, literally, on your study guide, is about this town. Well, I guess I can't call it a town. It's about this place called Metroville. And it's growing. So I'm going to use this population model. And if you remember what it looks like, let's see if I remember what it looks like. Yeah. This will show us the initial population of 23,000. The rate, since it's decreasing, is going to be a negative. So if I subtract 0.024, and remember to use a decimal, this will be my population model for Metroville. Now I don't really like the 1 minus 0.024, so I'm going to use 0.976. Then, we might just want to go through some solving next to answer the question. So there's your model. Now you want to know, when does it reach 10,000? So set it equal to 10,000, or you could even do this graphically. And how are you going to find time? Well, do some inverse operations and you're on your way. So first things first, let's divide both sides by 23,000. Next, you're going to want to take the log of both sides. I don't care which log. I like natural log. And last, you will be dividing by the natural log of 0.976.